joined the English. And I'm a Highland clan, and we never joined them at all. We never joined anybody, not even ourselves. Right, cross product, guys. We are going to eventually show you this very interesting property. We are going to show you a method that you can use to solve this very interesting, I think it's an interesting problem. Imagine that you've got two vectors, and I'm going to pretend that that angle's 30 degrees, so you don't think they're right angled. Wouldn't it be nice if we could find a third vector, and I'll call this vector V, that has the following property, that it's orthogonal to both those vectors at the same time. So, can you imagine these two pens represent A and B? Wouldn't it be nice if we could find the third vector, the red pen, that has the property that it makes a right angle with the green and a right angle with the purple? I don't know if you can see that, but it does, doesn't it? And that vector V is called the cross product of A and B. And it uses a capital X. So you would read that out loud as the cross product of vectors A and B. And that's what we're going to be focusing on today and tomorrow. How to get a third vector that's orthogonal, right angled, to the vectors A and the vector B. Now, before we do that, I'm going to have to do a little skill building exercise. And we're going to find the determinant of 2 by 2 matrices. Has anybody seen 2 by 2 matrices before and heard the term determinant? Have some of you seen that? Right. For those who've not, a matrix is just a table of numbers. A 2 by 2 matrix just means it's got 2 rows and 2 columns, right? That's a matrix. They're used in business a lot, right? I think computing also uses matrices. It's a very convenient way to store a lot of information. You might call it an array, but it's a matrix. It's just another name for it, right? So Rosie, you're nodding like computing do matrices or arrays.
Yeah, I've taken Java here, OC, and you use arrays a lot to organize data, because then each spot in the array can be called by its
position
placeholder in the,
yes.
Yeah, its position. So it's a good way to organize data.
So some people have seen these things. We are only going to be focusing on right now 2 by 2 matrices, right? 2 rows by 2 columns. And the thing called the determinant is a number, right? That's a scalar, a single number. And you get it by multiplying those 2 numbers together, which are called the major axis. So in this case, that would be 2 times 7. Take away these 2 guys, which are called the minor axis. So you'll see me going major axis, take away minor axis, you know what I'm saying. So 2 times 7 is the major, take away 1 times 5 is the minor, and what's that? 14, take away 5. So the determinant of this matrix, the 2, 1, 5, 7 matrix, is the number 9. Right. Now, when you do a determinant, you typically change the brackets and you make them vertical like that. So if I draw that, what I'm asking you to do is to find the determinant of this matrix. So you'll go 2 times 7 and you'll write down the number 9. Right. So let's do some practice and get determinants of 2 by 2 matrices. So 5, 0, 3, 1, 6, -1, -2, -1, and 1/2, 3, 2, 4. Right. Just randomly pick some examples. And for each one, we're going to get its determinant. So it's going to be 5, take away nothing. So that one is 5. -6, take away 2. So that's -8. 2, take away 6. Are you comfortable about how you can find the determinant of any 2 by 2 matrix? Would you agree it's just major axis, take away minor axis? Are we good with that? Have any of you seen 2 by 2 matrices and calculated determinants? Now, it's all a new skill today, right? You now know how to do it. Would you agree it's not the worst looking formula in the world? To me, it's very visual, isn't it? Major, take away minor. But why do we need that guy? Well, these determinants are used in calculating this fella up here, the cross product. The formula for getting the cross product is quite visual. There is a formula for it. And if you go and look up the textbook, you'll see the formula. And it'll be really ugly. And nobody that I know ever uses the formula. So I'm not even going to write it down. But you can go and find it if you're interested in how to get the cross product by using the formula. Instead, we are going to get the cross product of 2 vectors by a very visual technique. So here goes. Suppose my first vector is 1, 2, -4, and that my second vector is 3, -1, 2. I've just randomly chosen 2 vectors. Can we pretend that that's A, and we'll pretend that's B? Then we are going to find the cross product, A cross B. And this is how you're going to set it up. You're going to create a 3 by 3 matrix. And the first row is going to be our vectors. Remember our I, our J, and our K guys. Remember those? So the first row of your cross product matrix is going to be I, J, K. The second row is going to be 1, 2, -4. So your second row is going to be essentially A. And your third row is going to be B. Are you comfortable about how to create this table? The top row is I, J, K. The second row is the first vector A. The bottom row is the second vector B. Are we comfortable with that? Then it's going to be some number that I haven't told you about I, take away some number I haven't told you about J, plus some number I haven't told you about K. The cross product is going to be so many I's, take away so many J's, plus so many K's. So all I need to do now is tell you how to get the numbers that go here, here, and here, and you are done. Are we okay with the structure so far? Every cross product is going to be done the same way. The only difference is these numbers. So once you've done this one, you've done every single cross product in the universe, right?
Wait, so why is the J
Got a negative in it?
Yeah.
For a very technical reason that you don't need to know, except it does have it. And if you want to know the reason why it's a negative, it's to do with the right-hand rule. And when you do a cross product, one of the vectors points down the way, so it's negative. That's a very vague proof of why you need it. Can we just go, you need it, and leave it at that? Now, how you get the I, the J, and the K? Once we've done that, we're finished. Well, it's kind of messy. Let's suppose I want to get the I. You cover up the i's. Do you see a little baby 2x2 matrix left? What do you think I'm going to do with that 2x2 matrix based on what we just did over here?
Cross product.
Yeah, we're going to do that little determinant thing. So here we go. Major, take away minor. 4, take away 4. Oh, interesting. Now, probably can't use paper for this one. If you want the J guy, do you notice that you cover up the J's? Do you see there's a little 2x2 matrix? Major axis 2, take away -12. So 2, take away -12. And for the K value, -1, take away 6. Major axis, -1, take away 6. Now, what does that get me? It gets me 0i. 2 take away -12 is 2 add 12, which is 14, but there's still a negative going on, so -14j. And -1 take away 6 is -7k. Are you comfortable how we got the missing I, j, and k values? And me, because I don't like I, j, k notation, I like to finish by writing the answer like that. Are we good? Now, shouldn't this cross product be orthogonal to A and at the same time orthogonal to B? Wouldn't it be nice if we could check that? Not for homework, because you probably won't do it for your homework because it's a lot of work, but just to prove to you. I am going to find the dot product of A and my cross product guy, right? Now, A is 1, 2, -4. Dot product with 0, -14, -7. If A is perpendicular or orthogonal to this, shouldn't this dot product be 0? Agreed? Isn't that a way to check I've done it right? So let's see what we get. 1 times nothing plus 2 times -14 plus -4 take away -7. And that's 0, -28 plus 28. Am I good or am I good? Did it not work? Can you trust me that B dot A cross B is also 0? Have I convinced you that this weird way of calculating it has generated a vector A cross B? Right? Has generated a vector that's perpendicular to A and B. The orientation of A cross B, I think it's a left-hand draw. If you think of this as being A and this is B, do you see my thumb is pointing up the way? So when you do a cross product, you're going to get the vector using, I think it's a left-hand draw. If you're into engineering, I believe it's called the left-hand draw. Isn't that the same reason that X, Y, and Z look funny when you draw them? So that they've kind of followed that rule. Any questions about this technique? Would you agree it's a very visual technique? It's not really a formula that you plug numbers into, right? Okay, the best way to check something like this is to give you one to try, and then we'll do it. So A, B. So A is going to be 1, -2, 3, because I like those kind of numbers. 5, 1. We'll put a 0 in, that's always interesting. Right. I don't know. You got 3 minutes. Go for it. Find the cross product of those two fellows. For those who need help, I will set up the original start picture. After that, it's up to you. the last few things. Okay, here it goes. So we have IJK on the first row, A in the second, B in the third. It's so many I's, subtract so many J's, plus so many K's. Right, to get the I term, cover up that. Okay, what number goes here? Anybody?
-2 minus 3.
Be careful, is it -2?
No, it's 0. Oh
All right.
my gosh. So it's
Hey.
-3.
Yeah, easy done. And I guarantee I'm going to do that mistake sometime in the next 2 days as well. Okay, here's the second one. What's that one going to be? Anybody?
0 minus 15.
Okay. I know you didn't like them, but you know, zeros are very helpful. Don't they tend to make your calculations easier to do because one of the terms is nothing. How about the last one then, the K term? Anybody? What would that be?
11.
Agreed. 1 take away -10, 11. So we have got -3, take away -15, and add 11. And that was it. Do you feel comfortable, as long as you're careful, that getting the cross product is really just a pretty mechanical process, isn't it? Very visual. But as long as you stick to the structure of it, everything's fine. Now let's tell you a very interesting property about the cross product. Suppose I asked you to do B cross A. Now you might think, well, I already know this one, so this one's probably going to be the same. But it won't be. If you put 510 in the second row, which is what you should do, right, and the other one in the third row, right, because the guy that goes first goes here, and the guy that goes second goes here. Do you notice that these two rows would switch places? The answer ends up being so if you do it one way, your thumb sticks up the way. I'm going to hurt myself here, but if you turn it upside down, ow, that does hurt. Your thumb goes down the way. Do you see you're pointing the opposite direction? Does that kind of make sense, that the orientation of first to second does tell you point up the way and point down the way? Why is that orientation important? Very often these questions come from things called torque, where you have two vectors like a spanner and somebody turning it, right? So the spanner would be like the first vector and you're turning it in that vector. Isn't there a force going like this way? And if you do it one way, won't you be screwing the thing in? But if you turn the other way, won't you be loosening it, right? So in one direction, the force is trying to pull the nut out of the screw, and the other one is pushing it in. Or in engines, I'm sure I've heard the term torque, so I know it's something to do with engines, but I'm not an engine person. So cross products are used in torque. At least the magnitude of the vector is the torque, but the direction in which the vector is moving is the cross product. So order is important. First guy goes in the middle, second guy goes in the bottom. We cool? So being a very kind of engineering kind of thing, which you already know I'm not very comfortable with, I think I did that okay. You feel you know what you're doing? Okay. Are you looking at, I hope, the homework section 12.4? Okay, let's make it a little bit bigger, at least for my eyesight, it will help. I'll come back to them in a few minutes. Let's just look at the basic questions. Can you see that the vector is A and the vector is B, and you're going to do your cross product and it's going to go in there? Now, if your guy is in the form of components, right, those funny little brackets, and you want to do it correctly, hit the vectors button and choose that. And I know this is not the answer, but I'm just putting it in, you know, so I can put something in. That's how you put the answer in, right? Are we comfortable with that?
You can.
Yeah. If you put the less than and the greater than symbols that look very similar, right? I think WebAssign will just tell you you're wrong. So just
It'll take
that. Will it?
Yeah.
Prove me wrong, but I'm glad it proved me wrong. Still use those buttons. They look nice anyway. Right. Now, let's just pretend that that was the right answer. What is the answer to that calculation? A cross B dot product A. What will the answer be?
0.
It'll be 0. And if you do it with the other one, won't it be 0? So I could imagine that you're probably just going to go 0 and 0. Of course, if you get this guy wrong, right, won't this not be 0? Right? Now, WebAssign tells you you're wrong, so I guess you don't need to check. But isn't that check helpful if you were in a test and you wanted to be 100% sure that you'd done the cross product right? You can use the test on the dot product. But as far as doing it as normal homework, you probably don't need to do it unless you feel you want to. Would you agree this guy here is the same question, except you're given the question in the notation I don't like because I make mistakes. So essentially, that first vector is 0, 5, -7. Would you agree that's him? Right, and won't this guy just be -1, 2, 1? I like these brackets because it gives me a row of digits. The minute you put I, J's and K's in it, especially if one of them's missing, couldn't you put the 5 and the 7 in the wrong place if you're not careful?
I have a question. When we're setting up the matrices for like the typical vectors, not the IJK format, do you have to include the I, J, and K? Like it'd be 3 by 3, or would it be more like a 3 by 2?
If you did the IJK version, let me show you what that would look like, because my answer's pretty visual. And I think if you see it, it'll make more sense than if I say it. So if I picked you up correctly, let's suppose you had the question that A was 3i plus a j plus 2k, and let's say B was 2j minus 4k, right? And if how would you set it up? And you're asking, do you still use the IJK? Yes, you do.
I was
And
thinking for like a typical one, like the one on your left-hand page.
On this one
Like
here?
this normal one, yeah. Would you have to do the I, J, and K?
On the top row?
Yeah.
Yes, you should always do it.
Okay.
So that was an easier question. I thought you were meaning like if the question had IJKs, does the table need IJKs? It still does, right? In fact, aren't these just two different ways of saying the same thing? It's not that they're different things. They're the same basic vector, right? Oh, any other questions while we're still on this? Are you comfortable about you just do it because I tell you that minus bit, and it's very visual after that? If you're a visual kind of person, which I am actually. I like things like that. Right, now, let's go back to these questions. Explain whether these are meaningful or not. Meaningful means, could you get an answer, right? Now, the answer might be a vector, it might be a scalar. And if it is, you have to tell us that. would it be possible to do a dot product of A with a cross product B cross C? Would that work? Would you get something? Would A dot cross product get you something?
Yeah.
Yeah. And it would be a number, wouldn't it? So we'd say, yes, it's possible, it's meaningful, right? And it's a scalar. So the answer would be that one. How about A cross B dot C? Could you do a cross product with a vector A with the dot product of B and C? Are they compatible? Do they play well together? Nope, correct. Isn't B dot C a number? And if you're going to do a cross product, hasn't it to be a vector tying cross product another vector? So no, that is not meaningful. Right? So it's meaningless. And it would be that one. Don't jump the gun too quickly here. A cross B cross C. Could you do that? Yeah. It's sometimes called the triple cross product. And it actually has a meaning. It actually gets you something, believe it or not. Have no idea why engineers want to do that, guy, but evidently they do. Could you do a dot product, A dot B dot C? Yeah, that's a sneaky one. Isn't B dot C a scalar? Technically, if I made A the vector 1, isn't a scalar just a one-dimensional vector? Isn't a number just a one-dimensional vector? A vector with one direction. So technically, I would say that's doable. Could you do cross product dot other cross product? Would that have a meaning? And what kind of answer would you get? Scalar or vector?
Vector.
Oh, scalar. And why? Well, A cross B is a vector, totally agree. C cross D is a vector. But what do you get if you take a vector dot product of vector? Don't you get a scalar? A number is your answer. So there you go. Yeah. So basic skill building. Here's two vectors, get your answer. Here's two vectors, get your answer. Plenty of practice, right? You'll be really good at these. Do you think fractions are going to make any real difference apart from making the answer ugly? Nah. Oh, let's do that one because that is a little different. I have a vector A, which is t cubed, t squared. I'm just writing this down. You'll see it in a minute. And B is a vector t, 7t, 5t. And we are going to find the cross product of them. So as long as I stick to the process, I'll get the right answer, right? Well, if you want to do the cross product of A cross B, you have I, you have J, you have K. You must have those. T cubed, T squared, T, T, 7T, 5T. Are you all comfortable with that? I know I'm trying to sell this, but to me, isn't that just a more convenient way to write the vectors when you want to do this to it? Just an opinion. It doesn't mean I'm right. So it's going to be so many I's, take away so many J's, add so many K's. I tend to write it this way because I'm careless. There's a surprise. And if I just do them, I very often forget that subtraction. So if I write this down first, doesn't that kind of force me to do the subtraction? It kind of reminds me that it's there. So I then get pen, pencil, whatever it is floating around, and I'll cover him up. And the major diagonal is 5t cubed. Take away the minor diagonal, which is 7t squared. Then move to the middle one. The major diagonal is 5t to the 4, and the minor diagonal is take away t squared. And the last one, the major diagonal is 7t to the 4, and the minor diagonal is t cubed. And so it's 5t cubed, take away 7t squared. The negative of that guy basically just changes its signs. And this guy, not a very pretty answer, would you agree? But it's the answer. Here's a weird one. Let's do the cross product of I, which is 1, 0, 0, and J, which is 0, 1, 0. What do you think the answer is going to be? What vector is at
0.
right angles to I and J? If you go one in the X direction and one in the Y direction, what vector is going to be orthogonal at right angles to those two vectors?
One in the Z direction.
Which we call K. Does that seem reasonable? Let's find out. I cross J. These are the basis vectors, right? The vectors that everything is made from, the IJKs. So I goes 1, 0, 0, and J goes 0, 1, 0. And we'll do the cross product. So many I's, take away so many J's, plus so many K's. Right, I'll cover up the I's, and I get nothing, take away nothing. I'll cover up the J's, I get nothing, take away nothing. And I'll cover up the K's, and I get 1, take away nothing. And guess what? 0, 0, 1. We get K. So can you imagine this is what vector I would look like? 1 in the X direction. This is what vector J would look like. Isn't that 1 in the Y direction? Does it make sense that K would be the guy that's perpendicular, orthogonal to him? And can you now see why we draw the X, Y, and Z axes in that funny orientation? If I cross J is K, what happens if you go and switch the order?
Negative K.
Negative K. There is some questions where you deal with cross products, right? And they only contain an I, a J, or a K, right? So you get things like, what is I cross J? What is K cross J, right? Those kind of combinations. And here's a little triangle that I learned a long time ago. And it goes clockwise. And this little triangle is a little picture that helps me to remember what you get when you do cross products of two of these guys, right? And I put the I, J, and the K's in the wrong places. My apologies. I know what I wanted to draw. There we go, clockwise. There we go. I, J, K. Right. How's this little guy going to help us? We'll do the wrong one. Suppose you wanted to do J cross K. j cross k gets you I. You see you're following the direction of the arrows. What will k cross j get me? Well, if you do k cross j, don't you go against the arrow? So far, so good. Now, some other special guys. What do you think you would get if you did I cross I? What vector would you get if you did I cross I? I think there's two possible guesses. What would you guess it would be?
Is it 0?
It is 0, the 0 vector. In fact, A cross A is a 0 vector. So any vector in the universe, if you did a cross product with itself, you get zeros. How could that be helpful? Well,
Proving two vectors are the same.
this is true. That is very true. And they don't even need to be exactly the same. Can't they just be multiples of each other and the same thing's true? So if A and B are parallel, their cross product will be the 0 vector. So if two vectors A and B are parallel, then their cross product will be 0. Cool stuff. Put your last name down and bye-bye. We'll have more fun tomorrow.
Oh, can I make my announcement now?
Say again?
Can I make my announcement to the remaining people here?
Oh God, Rosie, I apologize. Rosie got something very important to say, so hang out for a few moments while you're typing in your last name. Go for it.
Okay, so the student government has a survey for students, and it's just a Microsoft form of your experiences at OC, like what's working well, and then what you would like to see improved. So here's the link for it in the chat, and it doesn't take that long to fill out. So thanks for filling that out, and so then a student government can know what you want to see change.
Rosie, could you shoot me an email with a very brief description of what you just said, and I'll send it out to the class in case they missed it at the end.
Oh
Okay.
yeah, sure. I will do that. Thank you, Professor Robertson.
No problem.
Thank you. All right, I'll see you tomorrow. Bye,
Okay,
everyone.
see you tomorrow, guys. I'll hang about for any questions until then. Tim, torque. You should know about torque because you're an engineer.
We deal with torque quite a bit, specifically like the torque on load transmitting members. So shafts. I deal with a lot of shafts. And
Did they talk about magnitude of cross products when they do that, or do you not even know where the heck the torque number comes from?
I cheat and I use a calculator that we have.
That does it for you. Okay.
There's actually a
yeah.
chart. So we have like a minimum safety threshold. I think it's 600%. Because if we drop something, it's really bad. I mean, you could drop 60 tons from 120 feet would really kill somebody good.
No, you could drop it for 6 feet and it would kill them. I don't think you need a lot of distance with that kind of weight. Right. So
But we also, like, if you have a crane kind of sitting and it sits on, like ours are all sitting on like railroad track. Well, a lot of them are sitting on railroad tracks. And then you have an arm that comes out, 100 feet. You have to know the load, and then you have to calculate the load on each wheel, and that's a torque. And that is actually, we do actually use vectors for that. And we don't write them like cross products, but we just write them as like the horizontal and the vertical form of a force, and then do a lot of math.
Okay. Victoria, what you got for me? It looks like you might have a question.
Yeah, I have a question for 12.2, number 13.
Is it a quick one? Can you say it out loud or we'll have to go looking for it?
Ooh, it's mostly about the angle part of question 13. like the
Okay,
co-
I'm assuming that's from the previous section, right?
Oh yeah, 12.2.
Let me go hunting for it then. It probably sounds to me like I'll need to
Yeah,
to read it because there'll be a lot in it.
unfortunately.
12.3, I should say.
Oh yeah, sorry. It's like whatever the dot product
Yeah, the
one
dot
is.
product.
Mhm.
And question number
13.
13.
It's the
Okay,
find the
it's
correct nearest degree
okay.
one.
Can you tell me who A, B, and C are? Because yours will
A-
be different from mine.
Oh yeah. So A is 1, 0, -1.
Mhm.
And then B is 2, -3, 0. And then C is 1, 4, 2.
Okay, so you want to verify that's the numbers you gave me?
Yep.
Okay, so really all I need to do is find one of the angles, because if we do that right, you just repeat it. So
Yeah.
let's suppose you wanted to find the first one, which is that
Mhm.
angle, right? Now, when I'm looking at this, let's just call this A, B, and C as a
Mhm.
placeholder. To get cab, I'm really wanting this angle, right? So I need to find AC and AB.
That's what I was doing. I don't
Okay,
know.
so here goes. AB is the vector 2 take away 1, -3 take away 0, 0 take away -1.
Mhm.
And what was the other vector? AC.
Yeah.
And AC is 1 take away 1,
Mhm.
4 take away 0, and 2 take away -1. Did you get those two guys?
Yeah.
Okay, we're on a roll then. The magnitude of this vector needs to be found, and the magnitude of this one needs to be found. This one's going to be 9, 10, 11, so square root 11. This one's
Yeah.
going to be 9 and 16, so that's a square root of 25, which is 5.
Mhm.
And the cosine of the angle between them, so this guy, we're going to call him theta now, is going to be the dot product divided by the magnitude of the two vectors. Now, the dot product of these two is 1 take away 0 plus that guy plus that guy over 5 square root 11s. Then I got my calculator and I take this guy, which is put a bracket around him, -12, add 3, close the brackets, divided, put a bracket around him, 5 times square root of 11, and I'm going to get a horrible decimal, which I do. And that horrible decimal roughly looks like -0.5427 and some stuff. And then to get theta then, I take the inverse cosine of that angle. And since it's a negative number, I know it's going to be bigger than 90. So let's find out what it really is. Inverse cosine of the answer. And I got 122.9 degrees. What do they want? Did they give an accuracy? Nearest degree.
Yeah.
So that's 123 then.
Mhm. Yeah, I put that in and it was not like in that one.
123?
Let me look at hold on, let me go back to my website. and
Okay.
see,
Don't
'cause-
put the degree symbol in because it's already got it in the box.
Yeah, I didn't put that in. Let me go to my website really quick because it
Sure.
was not like because I was trying different versions like -90 or like 180 and it just was not like in anything.
I mean, was
putting in.
this the way you did the first time?
Yep.
So you were on the right track. So whatever WebAssign's doing,
Not happy.
it's not happy. Maybe you typed in 132 because you were tired.
Maybe, yeah, let's see. Go to my website. Oops, wrong password.
Well, she's looking at that. I have just a kind of a really quick question.
Sure.
If we're happy with the average of our two test scores,
Yes?
Do we have to take the third test? I mean, if you're going to drop the lowest one anyway.
Technically, no, you don't need to take it.
I mean, I'm still going to do it. I was just curious.
Yeah.
Okay. All right.
Ha-
Well,
is it,
go ahead.
right, I was just going to say, are you there yet, Victoria?
I'm still looking for it. WebAssign takes a little bit to load. Let's see.
Okay, yeah, anything else, Tim, while she's doing that then?
Nope. I just I'm kind of curious now, if you don't mind.
Yeah, it was. Yeah, it's not happy about it still.
Okay, I'm going to go in and find your specific one
Or
and
maybe.
see what the heck it thinks the right answer is. So
Yeah.
let's click on this. Let's do a roster.
So I was
Let's find
looking.
all shooting space. Where are you hiding? I know you're here. I hear you. Right.
Mhm.
Roster, Victoria. There we go. Hit scores. That's good. Dot product. What question number was it again?
13. Maybe I entered it into the wrong one. That could have been
Oh,
a possibility.
maybe you yeah, it's possible.
I've done that before.
Well, I've done, you name it, I've done it. So, yeah. Okay, it doesn't have a correct answer.
Okay, good.
It's 123, just like I said, and
Okay.
it's CAB.
Okay. And then to find the other angles, how would we
Right.
do that?
Well, let's imagine we still got this picture, right?
Hmm.
We A, B, and C. But let's say we're after this one now, right? So this angle here would be called ACB, right? Oh, I'm not sure what you can see.
Can see
Can you
that.
see my white stuff?
Mhm.
Okay.
Yeah.
So let me try and close some windows so I can see. Yeah, right. So to get this guy, you need these two guys. So you need to find CB and CA. What could be happening is that you're finding BC and AC, or one of these is not the right way around. And you might think, it doesn't matter. It actually does. If the right answer is 80, but you do it the wrong way around, you're going to get the other number. You're going to get 100, not the A. Right? So if you were doing that combination, then the vector CB would be 1 take away 2, which is -1, 4 take away -3, which is 7, and 2 take away 0 is 2. And if you're doing the vector CA, it would be 1 take away 1, which is 0, 4 take away 0, which is 4, and 2 take away -1 is 3. You would get those two vectors. And the magnitude of this vector and this vector, 4954, so square root of 54, square root of 25, 5 again. And then you can do the cosine of this angle, which is the dot product of those two guys, divided by their magnitudes. And the dot product would be -1 times 0 plus 7 times 4 plus 2 times 3. And on the bottom, it would be those two guys. And that gets me, the top row is what, 0, 26. And that gets me 34 over those two. So let's see what that looks like. You do 34, then you divide it by the square root of 54 times 5. You get that horrible dip. Oh, that's not good. What did I do wrong there? I know it's wrong because I can tell that number doesn't make sense. So,
Does the 5 not belong in the square root?
well, it's the square root of 25,
Oh,
which is
okay.
5. I wonder if it's the bottom that's the problem. 49.54. Nope, it's the top that's the problem. How's the top a problem? Let's check CB again. 4 take away that is 7. Can't argue with that. That is 28. 2 take away that is 3. Oh, 2 take away. Oh, let's see. CA is 3. That's 4. And that's 0. Okay. CB 2, 7, -1. Okay, I see my mistake. 34 divided by bracket, the square root of 54, close the darn bracket, times 5. I was doing the 54 times 5 inside the square root instead of 2 separate things. Now it's good. So it's 0.92 and some stuff, and inverse cosine to get the missing angle. And that guy ends up being about 22 degrees.